Hey, welcome back to the course. So in this lecture and in the couple of lectures to follow, we'll play with 7-segment displays, okay, by interfacing them with the Beaglebone like hardware. I have already given links, okay, from where you can find 7-segment displays. You can find it in any electronics store, okay. And when using 7-segment display, okay, you should remember that there are two types of 7-segment displays. One is they call it as common cathode 7-segment displays, and another one is common anode. Okay, you can have any one you want. So here is a internal structure of the 7-segment displays. Okay, in the 7-segment displays, there are actually 7 segments. Okay, so like if you count here, there are 7 segments, right? So here there are 7 segments, and each segment is actually glown by its own LED. Okay, so that means if there are 7 segments, there are actually 7 LEDs. Okay, you can see here, and there is one decimal point here, and one LED is dedicated for that. Okay, so a 7 segment plus the decimal point, you can say it as, okay, there are 8 LEDs. Okay, so the term common cathode means actually negative, right? So cathode means negative. Okay, so in the LEDs, what happens is, okay, internally in the 7-segment display, all the negative terminals, that means all the cathodes, okay, are actually tied to a common place, okay, so that we call as ground point. Okay, cathode of all the LEDs are actually, they are common to ground. Okay, so that's why it is called as common cathode. Okay, the cathode is common. Okay, so you can control its anode by microcontroller. Okay, so that's why it is called as common cathode. Okay, so but in common anode, what happens is, the anode means, as you know, it is positive. Okay, positive terminals of all the LEDs are actually tied together, and you have to drive them to positive, okay, plus VCC. You have to control the negative terminal of the LED by using your microcontroller, okay, in order to turn it on or off. Okay, great. So that's why it is called common anode. So if you look at the 7-segment display, you can see that every 7-segment display will have 10 pins. Here you can see it has here 5. If you count from here, you have to count from here. Okay, so 5, 6, and this one is the 10th pin. And out of 10 pins, okay, 7 are dedicated for segments. Okay, 7 are for segments, and 1 is actually DP, that is decimal point, and the other 2 are either ground. Okay, in the case of common cathode, other 2 pins are ground. Okay, that means you have to connect them to ground point. Okay, and if it is a common cathode, then these 2 points will be plus VCC. Okay, so that means you have to drive them to plus VCC. Okay, so you need not to drive both the pins. Okay, you can connect either one of these, and you can leave one pin not connected. Okay, that works. So this is some background about the common cathode displays and the common anode displays. Okay, so now let's move forward. Now, how to connect 7-segment displays to MCU? Okay, so let's answer that question later, but first let's understand how actually we have to connect a LED to the microcontroller or to any supply voltage. Okay, so as you know, the LED usually has 2 points, right? So this is called a negative and this is called positive, right? You know, you have to supply voltage to the positive terminal, but you have to be careful while connecting supply voltage to the LED directly. Okay, because these LEDs will have maximum forward current ratings. and your supply voltage should not supply current more than this LED forward current rating. Okay, so for that, again, I'm going to take you to the specification of some LEDs which you can get in the market. Okay, here, okay, this Sparkpun is selling this LED, and here it is saying that this LED is actually having the forward drop of this much. Okay, that is 1.8 to 2.2. okay, so it depends on the LED color. Okay, and usually these kinds of LEDs, usually they have voltage drop of 1.8 volts. Okay, and it is saying that maximum current is 20 milliamps and the suggested current is 16 to 18 milliamps. So basically what they are saying is you should not allow more than 16 milliamps of current, okay, across this LED, otherwise the LED will burn. You should only allow the current less than 16 milliamps, okay, or at the maximum you can use 20 milliamps. That's it. Okay, so you have to obey these rules, otherwise you will burn out your LED. So that's why this resistor is used. So now how to derive this value? Okay, so let's say I am supplying voltage of, let's say, 3.3 volt. Okay, and we know that here, if it's, let's say this is a red LED, and we know that the forward drop voltage is 1.8 volt. Okay, and we also know that they are saying that don't allow more than 16 milliamps, right? Now let's say the forward current is 16 milliamps. Okay, the maximum forward current, this is actually max. So now how do you calculate this resistor? So R is equal to the source voltage, that is Vs. Let's say this is Vs. Okay, source voltage Vs minus the LED voltage. Okay, VLED, LED forward voltage. Okay, you can call it as LED voltage, divided by the forward current IF. Okay, okay, so this is a formula. So that turns out to be, this is actually 3.3 minus, we know VLED, that is 1.8. okay, and this is 16. Okay, so let me open the calculator, and 3.3 minus 1.8 divided by 16, right, into 1000. So you should use a resistor approximately equal to 100 ohm. So if you use 100 ohm in this scenario, your LED will be guarded. Okay, but usually, okay, even though they say 16 milliamps, you should consider still less. Okay, so it's better to consider this number as 12.5 milliamps. Okay, so if you consider this 12.5, so this number rises slightly, right? So okay, so that is nothing but taking some extra care about your LED. Okay, so this is the typical way of connecting LEDs and deriving the current limiting resistor value. Okay, so keep this in mind. Okay, this will be very helpful in your project. Doesn't matter you connect to what kind of microcontroller or what kind of batteries. Okay, so everywhere this idea will hold good. Okay,